Some of you who are listening to this today might have heard a little bit about geometric search engines. Some of you might not have, but I'd like to take the next few minutes to talk about what the software does and how it can help you. CADseek, simply put, is able to take any three-dimensional geometry, any 3D CAD file, whether it's SolidWorks, CATIA, Pro Engineer, Inventor, whatever, and is able to put it through an algorithm that's recently been patented. And that algorithm converts that geometry into a universal numeric language that is perfectly descriptive of that geometry. Now, what does this mean for you as the CAD user? It means that in the past you've had to search for your CAD files by file name, by description, by metadata, all methods that involve text searches. What CADseek is able to do is to allow you to search by geometry, because computers aren't very good at arranging things geometrically, but they're very good at arranging numbers geometrically within a search engine. So to the extent that the numeric languages are different, the geometries are different. To the extent that they're the same, they're also the same. So what you're looking at is a three-dimensional geometric library, and it's self-ordering. No human intervention was needed to produce this library. We just pointed it at a database and said, CADseek, put this in a geometric library, and it did it. So what is this? Looks disorganized, but it's not. It's actually a very, very organized by aspect ratio geometric library developed by a gentleman who specializes in virtual reality. This is a small subset of my database, but as you can see, these little squares that you're looking at are very geometrically similar when they're in the same neighborhood. And as you move along the x-axis, the z-presence becomes larger, and as you move down the y-axis, you move towards an ideal, which would be at the origin of a perfect cube ratio 1 to 1 to 1. The navigator, which is what you're looking at, allows you to narrow down things by number of family members. To be in a family, and that's one of these boxes, items have to be 95 to 100% geometrically similar. For example, this is a distribution of 30 parts. These parts are all extremely similar to each other, very nearly identical. The navigator allows you to narrow down the sizes of the families that you're searching for. For example, if you're looking for something that you expect to have a great many family members, you might say you want to see families of 20 plus members. If you're looking for something that maybe has a smaller number of family members, you would broaden your search. But every time that you do it, the CADseek navigator takes you to the proper view. What if you need something that is a broader search? You know it looks kind of like this, but you don't know exactly what you're looking for. You go to the distribution and you broaden your search from 95% to 75%. We click search. It picks that search target. We do a simple geometric search, and then within there it takes us to everything that is 75 to 100% geometrically similar. The result is that it's a lot like Google. You can take your search results and broaden from what you find. So now this is a little bit more of what I'm looking for, say this part right here. So I broaden again, and it finds me things that look exactly like that. And we go until we find what we're looking for. And this is very powerful, because before you would have to do searches by file names. Well, what if you're new to the company? What if you're not familiar with the nomenclature of the day? This allows you to find the part that you're looking for so long as you know basically what it looks like. A couple more features within CADseek that I'd like to talk to you about that illustrate the power of the software. You can also pull parts out of assemblies and do geometric searches on those. Take this part, for example. Within an assembly, I can double-click on any part, and it'll take me directly to that part. I'm double-clicking on these. I can double-click on that spring there, for example, select it, it turns yellow, and then with that selection I can do a separate search on it. And then it extracts it from the assembly. I search geometrically. Now notice in the bottom left-hand corner it says encoding model. That's because though it captures the geometry of every individual part in an assembly, it doesn't have separate codes for them. So what it does is when you pull it out of the assembly, it encodes it. Once it's encoded, you can then have it as a separate part within your database, or choose not to have it within your database. But in any event, you can still extract anything from an assembly, and it will find everything that looks like that part of an assembly. And there we are. Geometrically, in one set, it found these parts, a lot of springs, a lot of rectangular objects, but within the database it found those objects for us, and you can do that with any part in the assembly. This is just an overview of what CADseek is able to do, because right now we are really only scratching the surface of the power of this technology. The return on investment on the software is enormous. It dramatically compresses the amount of time that it takes to find parts. It dramatically promotes part reuse, and it dramatically helps purchasers to identify similar parts within other vendors' databases. With the problems in the engineering world today of part reuse, part duplication, and just the general need to save money, the power of CADseek is clear.